we're going to be looking at proportional reasoning and using unit rate in this case. Okay. This goes over the overall expectation to solve problems involving proportional reasoning and the specific expectation to make comparisons using unit rates. So we'll get right into the question. We've been given a word problem here. So anytime we have a word problem, we're going to read through it once and then highlight important information. So at first we'll get an idea of what it's about, and then we'll highlight what is important to our mathematical reasoning. So it says the table below shows the cost of water for 3 different customers. They each pay the same cost per liter. Here's our table. Take it in, take a look at it. And then the main question is asking us, Gabriel pays $46 for water at the same rate. Determine the number of liters of water that he purchased. Okay, so let's reread this again and highlight what we think will be important for what we're solving. The table below shows the costs of water for 3 different customers. We can see that. We have 3 here. So we have 3 to use. They each pay the same cost per liter. Okay, so that gives us an idea. Per liter is a type of unit rate. And I guess we should also highlight, let's go right to the question also. Gabriel pays $46 for water at the same rate. So apparently Gabriel is paying the same rate that the other 3 customers did. And we need to determine the number of liters of water that he purchased. Okay, so how many liters of water does he purchase throughout this? So using unit rate, we have 2 different amounts here. We have amount in liters, and we have the amount in dollars here. So we can technically find 2 different types of units. We have to figure out which one will be helpful for what we're doing. So it says here they've done cost per liter. So maybe what we'll do is we'll find the different types of unit rates for the 2 different columns and see which one is relevant. So we can do cost per liter, or we could do liters per dollar. There's 2 different things here. And one way you can set that up is always think of whatever you put on top, the bottom will be the per, or the value of 1. So what we mean by that in our first example here, if I do our 10,000 liters divided by our 9.20, this is, our 9.20 was our dollar amount, so I'm just going to put like a proportion here. Here's our dollar amounts, and here's our liters. So this is liters per dollar. Okay, because our dollar amount is on the bottom, our final answer will be per dollar. Okay, if we were to do that. Okay, and it says they pay the same cost per liter, so we could also do vice versa. We'll do it in red again. I could do 920 over the 10,000 liters. Okay, and that's our dollars above liters. So that's going to be dollars per liter. So in this example, when we divide, it's going to be per liter. So there's 2 types of unit rate here. We need to kind of decide which will be most important. So we'll test this first one out. We'll bring up a calculator. We have a calculator here, and I'm just going to clear everything. Okay. So in our calculator, we can start with our 10,000 divide our 9.2. So 10,000, 1, 2, 3, divided by 9.2. We can add that 0 there also. Okay, and our number, and we get a very large decimal here. So what we'll do is we'll round to the 2nd decimal place. Okay, so our 100th column, and it says we get 1,086 liters. We'll say 1,086.96 because it's a 6 value. We're going to round up. So 1,086.96. 1,086.96 liters per dollar. Okay. So every dollar we spend, that's how many liters we get. In our other unit rate, we do the opposite. We do 9.20 divided by 10,000. Okay. And in this case, we get a decimal place followed by 3 zeros and then our 92. Okay. So that's going to be 0.123. So 0.00092 dollars per liter. So we've set up 2 unit rates, and if we test the other ones, I'll quickly do that on a calculator. Okay, and actually what we'll do is we'll decide which one's going to be most important first, and then we'll test the other ones to make sure they're the same, and then we can apply it to the question. So we have per dollar and per liter. Okay, and we already know they pay the same cost per liter, so that's kind of in reference to our one on the bottom here. Which is going to be helpful for what the question is actually asking us. Okay, they've told us he pays $46. Okay, at the same rate. determine the number of liters of water. So we need to figure out how many liters of water Gabriel purchased, and we know that he's actually spent $46. Okay, so we don't know his liters. Again, liters is our unknown. So our second unit rate here of our per liter, this one's not going to be very helpful because liters is what we don't know in this question. Okay, the very first one we did is per dollar. So because it's per dollar, in other words, for every $1 he spent, we know he spent a total of $46. So we need to do some operation that would take us from 1 to 46. So we're going to scroll down here and take this information. I'm going to rewrite it again down here. So I have 1,086.96 liters per dollar. Okay, we found that unit rate. We know it's per dollar, so again, remember that's per $1 he spent. Okay, and if we need to take this amount and figure out how many liters he purchased, okay, how many liters are purchased, we're going to use an operation. It's going to be an increasing operation. Okay, so right now it's $1, and we need to take it to the value of 46. Okay, so we need to think about what can we do to take the number 1 to 46? Okay. Well, we can add something, and we can add it 46 times, which is very redundant if we were doing our calculator, but the word times should give you a hint of what operation we need to do. Because it's per dollar, to go from $1.46, we can also multiply by 46. Okay. So because we've now multiplied our per dollar by 46, we're going to do the same thing to our 1,086.96. We're going to multiply that by the value of 46. Okay, and that's going to tell us the amount he purchased in liters. So we're going to take this value and we're going to multiply it by 46. So we'll kind of write it on the side here as our side note. These are our side calculations. Do it in black. So we have 1,086.96 multiplied by 46, and that's going to give us our answer, and then we'll from there take it. So we'll put in our calculator, 1,086.96 times 46 gives us 50,000.16. And remember, we did a bit of rounding here. Had I taken the original number, which I'm going to show you again, so if my calculator, if I just click that value, I can take the original answer and multiply it by 46. I get 50,001. So there's a little bit of rounding. It looks like, and we'll round to the nearest whole number for liters in this case, he gets 50,000 liters in this case. Okay, so when we multiply those values, we get 50,000 liters. So I'll write it again over here. We don't have to write it again, it's being a bit redundant. But just to show you, sorry, it's not a dollar amount, it's a liter amount. He gets 50,000 liters for the $46 that he spent in this case. Okay, so we take a look at it there. And remember, we talked about before, we wanted to make sure that the other customers are doing the same thing. We can quickly check that. Okay, and remember our ratio or our unit rate that we used that we said was very important is we did it per dollar. Okay, so in that case, we're going to take each of the liters and divide by the dollar amount. So if I were to take that 20,000, and here this isn't important to what we've done, it's just checking to make sure that everyone paid the same amount. They paid that 1,086.96, and if we did it with the 30,000 and divided by their dollar amount, 27.6, we get the same unit rate again. So the unit rate was the same for all three customers, and that's the same unit rate that Gabriel had used.